I'd like to introduce Dr. Jeffrey Howe. Dr. Howe is a founder and chairman of the board of Dovetail Partners, Inc. For many of you, you've probably, if you read about green buildings and sustainability and many other and assorted things that they do, you may have heard of Jeff. He is a teaching specialist in the Bioproducts and Biosystems Engineering Department at the University of Minnesota. He's had a vast career of working in the forest products industry and in helping industry work better and become better organized and better managed. And Jeff is going to talk to us today about some of the research that's been done at Dovetail on green buildings, LCA, and carbon sequestration. Thank you.
Look at all the handsome, smiling faces. So, start the whole program right after lunch, so people can go to sleep. So, good afternoon. Wow. How many people have heard of Dovetail Partners, just out of curiosity? So, good chunk. So, one of the things I think Dovetail has done uniquely well is we tried to take the objective position between industry and environmentalists. We like to think we have both on our side and both against us equally in all the things we do. So we published a report not that long ago that we got complaints from both sides on about the same topic. So we figured, wow, as long as we're hearing from both of them, we know we're doing okay. So today I'm going to try to give you what I have, 3 hours, you said? Yeah, just about a little over 3 hours. So I'll be done by 5. Just to give you a quick, and this is the title, but on the idea that you're going to be talking about a number of things. We interact, as you do, with lots of different organizations all the time, whether it's environmentalists or individuals or organizations or industry. And I know you guys run into lots of questions from people. So I'm trying to kind of give an overview of what I see as the major topics, and most of them related to carbon. And kind of using carbon as a focus, because it is, if you look at the priority for most environmental investment these days on a global basis, it's really about climate change and carbon. I guess I'm going to talk about climate change in a bit, but I am going to just dust through a bit of that just because it's making sure we all have the same basis for conversation. So these are kind of the issues I'm going to some of these I'm going to go through really quickly, some of these I'll spend a little bit more time. There are individuals in here that know more about each of these than I do, so if we have any detailed questions, hopefully one of you can answer them. So then I'll try to cover this. I think some of the meat of the stuff comes at the end. I got some project case studies that have had LCA life cycle assessments done on them that looked at the actual impacts, the positive impacts of it. This is, overall, you could say this is a shameless promotion of wood, which seems like I'm preaching to the choir. Anybody against wood here? That's kind of disappointing. Nothing like a good fight. So just to start off really quickly, I thought it's hard to start a conversation that has anything to do with the environment these days without thinking about this issue, which is carbon dioxide in the atmosphere. You can see that graph. There's still some debate as to exactly what's all entailed in creating this high levels of carbon dioxide, and to claim that man is the only cause of this is probably crazy. But there's no question that we've contributed to this fairly significantly, and depending on who you are and how you are, those kind of things. We are off the charts in recent geologic history on these things. So I'm going to talk a little bit about the carbon issue related to wood very briefly, since someone else is going to talk about it. But I think everybody, I'm not going to go into this. If you're a student, we talk about climate, the basics of that, and greenhouse gases. I'm going to skip those two. And we know that there's more than, sometimes with wood we forget there's more than carbon dioxide. Particularly, and those of you that are emphasizing biomass energy, sometimes you run into that argument going, well, I'd rather leave the wood in the forest and let it rot versus burning it in a controlled environment. This issue here is how you have that discussion, saying to a certain extent you're better off actually burning wood than you are letting it rot in terms of the greenhouse gases released overall in that process. As long as you're in a highly controlled burning environment with a really efficient system, you're better off burning it than you are letting it rot. There's less methane, for example, being given off. Same with allowing wood to burn in the forest naturally. There are lots more toxins and dioxins and things like that given off in a wild, uncontrolled forest fire than there are burning in controlled. That's probably a biomass person will talk about that. That's why we bring about this. But fundamentally, we have this activity that's going on that we can talk about, and that's good. And so we get this giant global cycle going on that's gone on for from the early chart, hundreds of thousands of years. We know that's gone on for hundreds of thousands of years. And we know that man has changed this significantly in the last, we've been saying, most conversations recently have been talking about the last 100 to 150. We've been blaming it on the industrial age. Intuitively, we've known that man's had other impacts. I was just listening to NPR this weekend, and there's three scientists now whose research has been focusing on local climate change. But what they believe they can verify is they've been able to identify a pattern of climate influence by man over the last 5,000 years, specifically related to conversion to agriculture. They believe they've got an analysis of the data that suggests that we can track man's impact due to the land conversion going back 5,000 years. That's in that underlying land use category there, 1.6 billion metric tons a year, saying that there's a portion of this impact that goes back a significant amount of time. Where that's valuable, in my opinion, my humble but genius opinion, is there's been a lot of conversation, and Dovetail has put a lot of effort over the last 10 years into convincing LEAD that wood is better than any other natural choices are the best choices. Wood is better than any other natural choice. And in particularly, we've lobbied heavily to get rid of the rapidly renewable version, saying that a wood from a natural forest is dramatically better and has a dramatically better impact than wood from, say, a cotton field or a farm field or any of those things. Saying you don't do anything that wants to create more land use conversion from forests. Because this research kind of emphasizes that, saying we can point to that land conversion as being a significant contributor to climate change for 5,000 years. So when you look at this big issue of global carbon around the world, and everybody's probably heard of Kyoto, and everybody said, let's reduce our emissions from the 1990 level. We basically said there's two ways to do this. You can do this voluntarily or mandatorily, or mandated. And the big thing, of course, we're trying to address is emissions. We can do that by regulating emissions. We can do that by incenting renewable or other choices, and we can try to get more trees to grow. It's pretty simple. So what's happening talk a little bit about what's happening in the forest. I'm not going to go into detail again, but everyone's seen this slide 1,000 times. Anyone who hasn't seen this slide 1,000 times, which basically shows our forest land area, which is often very confusing for non-professionals. They don't understand the difference between forests and forest land area. They think that harvesting a forest means we got rid of forest land, and they put those two together. And so we always have to be careful when this slide actually deserves more explanation than it usually gets depending on the audience we're talking to. We've run into that over and over again. People confused that forest harvest, it gets rid of forest land. Not true. We've probably also seen this one. And this is on a national basis. On a regional basis, this isn't true. There is a measuring stick you have to decide on. How are we going to evaluate ourselves? Are we measuring ourselves regionally, on a national basis, or globally? If you argue on a global basis, this graph is not correct. But on a national basis, an area we have relative control over, it makes a lot of sense to use. And we have significant more growth today than we did 100 years ago over harvest. And we look at the resultant standing inventory is high. You can even look at, if you just look at what's happened to the U.S. population over the last 50 to 100 years, we've doubled our population and we've increased our harvest. Both have occurred. And so what's happened, and if you look at it, that's astounding to many people. This is an astounding statistic. When you talk to the public in general, we've got a lot more people, we're consuming a lot more wood, we're harvesting a lot more wood, and there's a lot more wood in our forest. They're going to go, for most people that doesn't make sense. They go, how can that be true? How can you cut down more trees and have more wood? So I think that's an opening discussion to a lot of things because it's a great statistic. So when you bring it back to carbon, is there more carbon too? And this statistic shows that there's also more carbon being stored in the above ground portion of standing trees. So do those trees have more carbon? And how about the soil? How are we doing in the soils? Are we destroying the soils? You can say, no, the soils, we're even still storing about the same amount of soil in our carbon in our soils. So the soils aren't being destroyed in this process either. People are always looking for what's the hidden bad news behind the story, and there isn't much. There is some. This shows the cumulative effect of harvesting. This is one of those slides that shows the green at the bottom shows forest carbon storage through multiple, in this case 3.5 harvest cycles. The tan intermediate thing shows wood in storage, and it's an attempt to demonstrate that some of the wood that's harvested goes into storage for fairly long periods of time, and how it tends to accumulate over time. And so you can see that the average stored carbon goes up over time when we put wood into durable use. This is another way of looking at it. This is, and I don't know the document that Pat's referring to, but this is the building with wood. Have any of you ever seen the building with wood document that Dovetail put out through Forest Innovation Investments and stuff? It's actually quite good. It's based on a German version that came out about 5 to 10 years ago. It's available to all of you. It's available both in a form that's usable, that's visible on an HTML format, so you can see it on your screen, the way it would look for your formatted for computer screens. It's also available in a printable format, so you can print it. Actually, there are a few books that have actually been made. It's actually got lots of really good information. We put a year and a half worth of how do we get good graphics and good statistics and good communications aimed heavily at architects. This was the dominant target audience for this book, but it's about 24 pages of juicy tidbits of information about carbon storage and things. So it's available for free, so I encourage you. But this is an example of one of those statistics. The goal is to show that through harvest cycles we get logs, those logs go to the houses, and over time you accumulate houses. And as long as we have more houses today than we had in the past, we've got more carbon stored in houses, even if you're tearing them down every year. As long as you net more, you're net storing more carbon. As long as you have net more furniture out there than you had 20 years ago, you have net more wood stored in furniture. As long as there's a net increase in consumption items, you're getting net more carbon in storage. So that's another one of those issues that people need to understand. It's the net change that matters. It's not what the annual activity occurs. So, and this is the statistic that's designed to help store that. So wood stores, we know wood stores, for those of you, anybody a carbon scientist out there, this is kind of I just use this to remind me of the realities of teaching class. Photosynthesis is a very simple formula. I teach the introductory wood science and engineering class at the University of Minnesota, and it's also available to a lot of environmentalists take it out because it's a biorenewables resource class. We usually sell out at 100, and at the very beginning of the class I show them the actual formula for photosynthesis, and I tell them, just so you know, this formula, this first slide I show, so this formula, not this one here, but this formula will be on every quiz, on every homework, and on every test. So I'm giving you free information. I can tell you I have never in my history had everybody get it correct on any particular one of those things. 100% of the students have never gotten them correct. So it's, how you get people's attention on these very simple things is interesting. So just a little, this is just basically demonstrating that wood, as we know it, the dry wood is about half carbon. So there's some real significant benefits to using wood, storing wood, and the carbon issues. So, and this is a graph that goes with those previous graphs that show that it's believed that we're net increasing our carbon storage in products. So that's part of that. We are actually measurably increasing the amount of carbon stored, even though things are coming in and out of use. So again, this is that short-term use question that says, yes, but we're going to throw furniture away in 20 years, or we're going to tear a house down in 80 years. You're going to go, yeah, but it doesn't matter. It's growing. This is just a reinforcement to that discussion. So, and this one we all know. If you didn't know this, surprise. But what we tend not to recognize or not even know as much is that it takes very little additional energy to convert wood into useful products. In fact, in regions of the country, in some regions of North America, as much as 95% of some regions, wood is exclusively produced using biomass energy, both for electricity and for heat. Most of Canada does that. There's lots of places where that CHP is the common way to manufacture. They're not using any energy inputs. There's no fossil energy input. That is something that's hard for people to fathom. It's hard for people to understand. There are no fossil energy inputs into a lot of wood products. It's such standard practice for us. We take it for granted. But it's underlying data behind all of the conclusions in all life cycle assessments, that we're not putting other inputs into the process of making stuff. So, and that's the basic truth. And so the result is, when you look at things like let's go back to this. When you look at carbon emissions from all these different materials, these individual materials, framing, lumber, concrete, all these kinds of things, there are emissions on all of these. When you add in net emissions, including storage, you can see the wood products are the only ones that are negative. So that's dramatic when you're looking at building anything. There's no other product, major industrial raw material, that has negative carbon emissions when you use it. So it's why it's becoming so popular, particularly in Europe. You're seeing whether it's the tall buildings movement, where we're starting to get 10, 20, 30, 40, 50, etc. story commercial buildings being built out of wood. That's part of that movement, is this carbon storage issue. It's in the background behind all of those things. So wood is really unique in that regard. You can see down the bottom, molded plastic it does store some carbon, but it does not offset the emissions in the production of plastic. So someone says, well, what plastic is made out of carbon? Yes, it is, but it takes lots of energy to make plastic, so it doesn't offset it. So it's one example. So not only do individual materials store carbon and have low net emissions, but also when they do life cycle assessments, this is a quorum based on a quorum report. You look at wall systems, in buildings, and say, what about that whole wall system when you combine it with other things? How does that come out? And if you look at the bottom here, you see these individual products, and you put them together into wall systems, and you can see that the wall systems, even when you add things like vinyl onto like vinyl siding, in this case is what they're referring to, onto the wall system, you still have negative emissions. So the storage capacity of wood is such that it helps the whole system work better. So in combination, and you can see it significantly improves even steel. Steel OSB vinyl, adding OSB or vinyl significantly improves that. Just adding some wood to the package. And you'll see this in some of the life cycle assessment examples I have at the end here, that you don't have to make a whole building out of wood. That's not what it's all about. The more we get wood in any way possible into buildings, the better those buildings perform, and the amount of emissions are reduced fairly dramatically. So, and in general, for every ton of wood used, you're saving 2.1 tons of emissions of 2.1 tons of carbon, or 7.17 tons of CO2 equivalents are avoided. So here's some examples. So we're going to talk through the meat of the discussion here. So I've got 4 case studies, and some of you may have seen these before. All of you may have seen these before. You won't have seen these exact slides before, because I just made them, so I can really help for that. But I'm going to look at an individual house, like a single house. I'm going to look at a school, an Olympic facility in British Columbia, and that last one's, I must have been eating M&Ms when I did that one. That's supposed to be Minnesota. So an apartment building that's being constructed in Minnesota. So I took 4 examples. Increasingly, there are lots of examples out there. There have been a lot of good life cycle assessments done of buildings recently in the last 3 years. And there's lots of good data about how wood in buildings is performing from a life cycle assessment. But I tried to pick 4 diverse examples. So let's look at this is a raised floor home in New Orleans, and And this is the analysis. And here's a description of how it's built. There's a little picture of it. You can see it from where you are. And basically there's a lot of wood used in this home. I mean, it's got wood pilings pounded into the ground, and it's a 2-story out of wood, and a lot of it's like pine, and all those kinds of things. So if you look at it, there's 15 cubic meters were used, which sequestered about 30 metric tons. If you remember the last statistics, 2.1 tons per cubic meter, roughly, approximately. And then avoided greenhouse gases of 60 metric tons, and total carbon CO2 equivalent benefits of 90 metric tons. If you go, when you hear the climate change discussion, think of these numbers when you start talking about what's accumulating in the atmosphere annually. These have a significant, these numbers in each of these buildings, when you add them up, are having a significant impact on the total carbon emissions, especially in the really big buildings. You actually can have a measurable impact on carbon emissions in a region by doing things like some of these big buildings. So if you want to compare the impacts, this raised floor home in New Orleans, the carbon savings is the equivalent of taking 16 passenger vehicles off the road, or the savings of enough energy to operate a home for 8 years. So this one home had that kind of an impact. So there's an exponential impact to doing this, even in a single residential building. Right, let's move to something. Let's go to Corona, California. Yeah, let's go to Corona, California. Look at an elementary school. In elementary schools, they're not going to be as wood intensive as a residential building, most likely. But with the wood frame, the walls, the roof, and the second floor level floors were all wood in this case. So this one did have a lot of wood in it. It wasn't almost 90% wood like the previous one, but this one does have a lot of wood in it. And this is a normal classroom with all the different kinds of rooms you get in a normal elementary school. So it has all the different kinds of rooms and facilities that you'd get. It's got bathrooms and everything. All the kinds of things you'd expect in elementary school. So there's nothing unusual about this building and its performance other than it added a little bit more wood. So in this case, 4,000 cubic meters of wood were used. It sequestered almost 3,500 metric tons of carbon, CO2 equivalents. That one should be, that should be just carbon dioxide, and carbon equivalents of 7,400. And the total carbon potential benefit is almost 11,000 metric tons. So you're having a very measurable impact on the environment by sequestering this kinds of carbon in this building by using wood. So, and again, if you for the layperson like me, that if you look at the carbon savings, it's the equivalent of 2,087 passenger vehicles off the road in a year. This one school building is the same as taking 2,000 cars off the road for a year. It's also enough energy to operate, it saves enough energy to operate about 920, equivalent of energy consumption that would run for 920 years for one home. So you can grab all kinds of ways to make this comparison, try to be a little random, but trying to demonstrate the relative impact, that you can have a really big impact with an individual building. I think that's the goal of these kinds of things. We have other building examples. This one's my favorite. This is the Richmond Olympic Oval in Richmond, BC. If you've been there, it's quite a building. I like it because it used 1 million board feet of SPF. Technically that's called a bunch of wood. So if you're professionals, probably don't use that kind of language, but it is. And it was dominantly in the roof. So this is a case where you don't have to use it everywhere to have a huge impact. 1 million board feet went into building dominating the roof. And in this particular case, they were able to utilize wood from mountain pine beetle problems. So they're using wood that was killed in other ways. So the volume of wood is about just under 5,000 cubic meters, and the amount of carbon sequestered is again just under 4,000, 8,000 metric tons of CO2 equivalent, and almost 12,000 so a significant benefit. So this is, you see, just doing the roof can have a dramatic impact. Again, you're taking equivalent of 2,200 passenger vehicles off the road. or enough energy to operate a home for 1,000 years. So reducing emissions from that, into that respect. So these are, you can demonstrate really big impacts. And so I don't know why you would have an argument about whether you use wood or not in these cases. Also, it's a beautiful building. It's pretty spectacular. So it's not only a great choice environmentally, it's just how do you get nicer than that? And I have to add an aside if I can, because for years we've been having a debate at Dovetail about why wood in a room feels good. And there's now research, and we found research coming out of Germany that's actually demonstrated why, and we always intuitively thought we knew why wood. When you go in a wood room, it feels more comfortable than a regular room. There's research in Germany now that's demonstrated that the acclimatization factor of wood, meaning its ability to give off and to regulate relative humidity, if you have sufficient amount of wood in a room, the reason it feels more comfortable is that it has a stabilization on the relative humidity in the room. They can actually measure that stabilization. So when you go into a wood room and go, oh, this feels really comfortable, it's because it does. It's because it's got a more stable relative humidity than other rooms. So wood's, sorry, that's my shameless side pitch for wood libraries. So this gives you an idea, the summary. And then the last one we're going to talk about is the Copperfield Hills Apartments in Robbinsdale, Minnesota. Spelled Minnesota right this time. And this is just a traditional apartment building in the suburban suburban area of the Minneapolis Twin Cities area. And this one's looking at the volume of wood used. You get the same kind of numbers in slightly smaller volumes. So it's the same story, telling the same story over and over. It doesn't matter the building. You don't have to do all of any building. The same story is true. You're having a dramatic impact no matter what you do. And again, this one's just showing different proportions, same result. That's all you're getting out of this. So that's all I'm talking about. So, any questions about those 4 examples? No? So basically, if you're having a discussion about wood, there's really, carbon is the fundamental focus of so many things today. There's so many countries for which carbon is the focus. In the Southeast, you're pretty familiar with that, given all the export of biomass to Western Europe. And part of it is giving you some of the information, just trying to give you a highlight here of some of the parts and pieces that are related to questions we usually see being asked, and some of the things about wood some of the data from wood in general speak that allow you to have those discussions. And the fundamental basis is that we've demonstrated over the last 50 or 100 years that we can use wood and have forests increase. That's a pretty dramatically unusual. There's no other material that can claim that. And there's no other material that you can actually have more of when you use it. And often in that debate, we often use the example that says, if you have, and people often ask you, they don't believe that statistic. So they go, so to explain that discussion, we often use the example in agriculture, saying, so if you have an apple tree and an orange tree and everybody only wants apples, 5 years down the road, what's the likelihood you have orange trees? Or 10 years down the road? The answer is you won't. You'll convert those orange trees to apple trees. If people only want apples. And the same is true with forests. If we stop wanting forests, then we're not going to have forests. And we know that for 10,000 years we've been converting forests and continue to do so globally to agriculture. We continue to do that, and we're still doing that in some regions of the United States, although less so than ever before, and usually in minor amounts. In fact, forestry, if you go back to that chart that shows how level we've been in forestry, forestry is actually the only major land use that is stable. We've been losing cropland and we've been losing rangeland to development for the last 50 years. We've been able to make forest land pretty stable. So, and with some recoveries and other kind of things. And well-managed forests are gaining carbon and all those benefits. So there's really very little bad news about it. So, and obviously if you're talking about carbon or any environmental issue, wood is clearly part of the solution.